Hello, everyone. Good morning, good afternoon, good evening, depending on where you're joining us. Thanks for taking the time to be with us on this session today, and welcome to the Data and Telemetry Award webcast, presented to you by our Shalika Marathon technical experts. So I would like to take the first few minutes of this session to go over some safety rules. Even in home office mode, we still consider safety as our first and primary priority. So please do not take this call while driving, even if you're using a handset or a hands-free device. This session is being recorded, so you don't need to take this in an unsafe environment. So please get to a safe location before you start asking questions or listening to this webcast. Be aware of your safety procedures in the location where you are, fire extinguishers, emergency exit routes, muster points, all of that. Be aware of your surroundings and know what to do in the event of an emergency. If you're using a headset, please make sure that you're still able to hear a fire alarm, so don't set the volume too high. And to submit questions, we will have a Q&A section at the end of this presentation. To submit your questions, please use the Mentimeter box on the right side of your screen if you're joining from a desktop, if you're using a computer. And if you're on a mobile device, please click on the Q&A button at the top of the screen, or open a new page and go to menti.com and use the code at the bottom of the screen that's showing here and will be showing on the other slides as well. So the code is 9156404. So if you go to menti.com and type that code, you should be able to submit your questions for this webcast as well. We will be answering the Data and Telemetry of Trek Award questions in priority. But depending on the time and how the session flows, we might be able to cover other topics as well, but that's not a guarantee. So as you know how to find us if we don't have time to take all the questions, or if there's something that is slightly off topic for the webcast today. You can find us on your regional inboxes. So for Americas, that's EcoMarathon, Americas@shell.com. Asia Pacific and the Middle East region, the address is eco-marathon-asia@shell.com. Finally, Europe and Africa region, shell-eco.marathon@shell.com. And just to get started today, just to give you an overview of where we are exactly in the season, the 2021 season of Shalika Marathon. As you know, we've had our first virtual competition, which is Pitch the Future. That was a huge success. We had a lot of teams participating from all over the world, bright ideas, a great experience. And we still have 5 ongoing virtual league competitions happening. Currently, we have open the autonomous programming competition that has already started. And just as a reminder, technical submissions close on February 19th. We had a first bonus challenge as well, a very fun Shalika Marathon quiz. And also open right now for submissions is the Virtual Off-Track Awards. It'll go over the month of February. And we still have, finally after that, the virtual technical inspection, which will take place during the month of March. So with that being said, and of course, if the conditions allow for it, the safety and health conditions of the pandemic situation, we plan to have the mini events, as we're calling them. So these are smaller Shalika Marathon track events. We have the provisional windows, dates, and locations on our website, and you should have received as well the communications for that. But yes, as you know, this is all pending on the development of the situation. So this is where we are in the season. We hope you're having a great experience in Shalika Marathon 2021. And without further ado, I'll hand it over to Marco with the Schmidt team to actually get started on the technical part of this presentation, which is what you're all here for. So thank you, Marco. Over to you.
Yeah, thank you, Priscilla. Yeah, I'm Marco Schmid. I'm the owner of Schmid Electronic. I'm with the Shell Eco Marathon since 5 years, for 5 years. And normally when I'm at the events, you find me at the tech inspection and I'm squeezing into the cockpits or I'm putting my head into the engine compartments. And I walk you through the webinar today. We go through several chapters today. We start with an introduction of the data technology team, of the telemetry system and the award. And then we dive into 3, I would say, hands-on technical sections covering the onboard computer, covering the live data, and also covering the log file data processing. That will be followed by the next step, how we can prepare for the award, what you expect from you, and then we move into the Q&A. That's what we cover today. The overall objective, the telemetry system itself and the system and the data, they have been used until now for the World Championship as to give you a new live experience, and we want to leverage the technology to the mileage challenge to improve the team's performance and to improve the results. That's what we are here for. And that's why the focus of this webinar is manifold. We want to really give you a hands-on demo, how the data flows from the sensor to the cloud server, to the log files, and also to the visualizations. We want to give you an idea of what data points are available today. We want to create an avant understanding, what we expect from you. But most of all, by showing you hands-on how we use the data, we want to spark ideas. The basis is the article 102. It's about the recognition of the conceptual design of how to use the data. It's about exploration of live data as well as processing of static log files. You can use the existing Shell telemetry data, something like GPS data, energy sensors, IMU, if you will. But there are also additional data points you might consider of, something like video streaming, something we would never have thought about it. Invited are the teams of urban concept class, as well as the teams of the prototype class, because the future roadmap, as you will see shortly, will also support the prototype class, and included are all the 3 energy types. The webinar today will be presented to you by the data technology team. We are, I would say, kind of a startup within the tech team. They're also known as the blue shirts. And as the name says, we care for data processing, we care for new technologies and leverage that technology into the Shell Eco Marathon. And the faces you see here, maybe you recognize some of them when you have been at the physical events. And the ones highlighted are the ones that will be talking to you today. The webinar will be hosted by Schmid Electronic. We happen to be a partner of the Shell Eco Marathon. We are also part of the data technology team. And we provide services, something like software, hardware engineering. We provide our platform to the event. And also we provide electronic production services to deliver proof of concept, prototypes, minimum viable products, pilot series, and also series production. And as you can see, we are a family-owned, family-driven, small, medium-sized business in Switzerland. And we kind of manage the balance between the traditional and the new, kind of. We also happen to be an NI Alliance member. NI, as you know, is a kind of a de facto standard in test and measurement. We have a special role here, speciality. We do platform completion. So we do kind of create a last mile between the NI standard and the real world, starting with embedded systems, test systems, and automation. And this technology brought us into pretty cool, exciting projects. So they range from LiDAR in meteorology to 2D laser scanning in railway, from automation, or from condition monitoring to test systems for inverters, from condition monitoring of gas pipelines to cyber physical systems for a solar power plant. Our job here was always to provide the hardware platform together with a software stack so that the end user was able to create his fantastic application. Schmid has a very strong green engineering background and history, and that's brought us finally to the Shell Eco Marathon. So our applications always had to do with power electronics, mixed signal battery technology, lasers, electro-optics, inverters, and that brought us into connection with the Shell Eco Marathon, with the efficient vehicles, the clean energy, the clean mobility that happened in 2015. And our main touch point with the Shell Eco Marathon is this onboard computer and the energy sensors, and that brings us now to the real thing of today's webinar, the telemetry system that starts with this onboard computers that are mounted on the vehicles, that are kind of connected with the engine compartments, that are connect with the cockpit. They connect the vehicle and the surrounding vehicles through the IoT with a cloud server and send data to this cloud server. And from there, we use the data to create live data and visualizations, and we store log files that are finally then accessible through the QR codes. And what you see here on the screen, this onboard computer, the live data and the log file processing are kind of the nuts and bolts of this telemetry system with the cloud server as a backbone. And we want to now open the hood of these three areas to let you know how we use the data and how the data flows within the system. And with that, I hand over to Benny and Martin for the onboard computer, and I would say the stage is yours.
Thanks, Marco. I'm Benny Ammann. I'm project lead here at Schmid Electronic, and I joined the Shell Eco Marathon family in 2016, helping to raise the telemetry baby. And now let's have a closer look at what the telemetry system is. Here you see the telemetry system, how it is installed in an urban concept car. On top of the car is the yellow OBC pod with all the antennas that send the data towards our server. And on the inside of the car, the blue part is the backbone where all the sensors are connected to. It has its own battery and so does not draw any energy from the car. The energy consumption of the car is read by dedicated sensors, symbolized by the rounded squares below. These sensors are transmitting their values over digital interfaces to the backbone and onwards to the OBC. The OBC takes the data that receives it, aligns it, stores it, and finally transmits it to our servers. The relay on the right side is only used for World Championship races. If wired correctly, it stops the propulsion system when more than the given energy is used. We take a deeper look at the sensors on the next slide. On the left side of this slide, you see the joule meter. It measures voltage in millivolts and current in milliamps and calculates the electrical energy. At least one joule meter is installed in all cars of every energy type. The hydrogen gas flow meter in the middle of this slide is only used in hydrogen cars. It measures the amount of hydrogen consumed by the fuel cell. The ideal gas law tells us that volume, temperature, and pressure are interdependent. The sensor takes care of all of that. The liquid flow meter on the right side is used in internal combustion engines that use fluids as their main energy source. It is a very accurate piston flow meter that produces 6,000 pulses per milliliter. Since the density of gasoline, diesel, and ethanol varies with temperature, we are also measuring this parameter. The next slide shows how this is done. We've embedded a printed circuit board with a microcontroller inside the flow meter. This allows us to digitalize the values right at the point where they are measured. The microcontroller converts the pulses to flow in milliliters, corrected for 15 degrees Celsius, and integrates the values over time. This way we get a smart sensor that transmits its value to the OBC via a CAN bus. CAN stands for Controller Area Network, which is a very robust digital bus, and it is designed for the use in vehicles. The same principle we've applied to the joule meter, as you can see on the right side. This is the next generation of the joule meter. It has also a CAN interface that proved to be much more robust than the USB interface of the previous version. Another sensor that is embedded on the OBC itself is the GPS sensor. To have an accurate enough position information, the OBC needs at least 7 satellites in direct view whose signals it can work with. We do not always have perfect conditions at the racetrack because of buildings close to the track or even bridges above the track. That causes some signals to be completely blocked, or even worse, we have signals that get reflected. In this case, the distance and time the signal uses to get from the satellite to the receiver gets longer, but makes the measurement inaccurate. In the past, we've seen a position information of a car that pretended to be in a nearby shopping mall, while in reality, it was on track. Well, the position system we are using in the current OBC is a standard GPS receiver, like it was available at the time when the OBCs were designed. But technology has evolved since then. We are currently testing new modules that incorporate the following improvements. Firstly, multi-constellation. This means that not only the US GPS system, but also the Russian GLONASS, European Galileo, and Chinese Baidu satellites can be received. Secondly, we have multi-band. Most of the satellites transmit on multiple frequencies, and this way some of the errors can be ruled out. The third improvement is real-time kinematics, or short RTK. A fixed base station provides correction information to all the OBCs. And the fourth improvement is an inertial measurement unit that we use to calculate the position from the measured acceleration when not enough satellites are available. The next slide illustrates the constant development we are performing to improve the telemetry system. On the left side, you can see the prototype, a big, ugly and gray box that has been tested in Manila 2016. In the same year, we developed the much smaller blue box. From the knowledge we gained from this system, we developed the current OBC. As it has been in use for the last 4 years and is currently used. But we're not stopping here. We are already in the development of the next generation OBC that incorporates new technology and will be small enough to be installed in cars of the prototype category. Now let's have a look into the software of the OBC, and for that I hand over to Martin.
Thank you, Benny. I'm Martin. I work as an embedded software engineer at Schmidt Electronic. I'm going to show you some software insights on the telemetry software, on how we collect and forward data. On the graph, you can see we have a service for each sensor, shown in yellow here. The service reads the physical interface from the sensors. So it means serial for GPS and joule meter. It means the CAN interface for liquid flow and gas flow meter. The service extracts the sensor data and forwards it to the data accumulation. Data accumulation merges the data from all the sensors together and stores it into a log file and sends it to the cloud for monitoring and visualization. So again, the data flow bottom up, it's reading from the sensor, it's data merging, and then forwarding to cloud or log file. Let's follow up one data point on an example on the GPS data. The first point we can see that the data is right after the physical interface. Let's see on how that looks like. What you see on that slide is the outputs directly from the GPS module. It's the NMEA format, a little tricky to read manually, but you can already see the GPS coordinates. After reading the data from the serial interface, the service picks the data we use and forwards them on a TCP connection. We can see the data here on the TCP connection. Already much simpler because we just chose some data. You can see the GPS coordinates again. Now, next point, we can see the data are in the log file. It contains the data of all sensors merged together. So we can see now the GPS coordinates again, but you can see as well the data from all the other sensors like joule meter, gas flow, whatever you have. On the other hand, we can see the same data which are stored in the log file. We can see them on the cloud. These are the same data, but they're in a JSON format. And this JSON string is sent to an MQTT broker. And that's where Melee and the live data processing comes into place.
Thank you, Martin. I'm Melle de Wit. I've been with the Shell Eco Marathon for just over 6 years. My responsibility is for everything related to cloud infrastructure, server-side software, and some of the visualizations that we show around the track. So I'll talk to you just a little bit about how we as the data and technology team use the live data. As Martin mentioned already, the OBCs send their data to an MQTT broker, a standard IoT service in the cloud. We aggregate all the data. We process it through an internal SEM kinetic service that we use. That validates the data first of all, and then stores valid data into the database for further processing post-event. We use it to display in our personal dashboard, the OBC manager, and we send on the process data for external visualizations. So the kinetic service is a service that we built specifically for this purpose. At every event, we create a node map of the track. We take the GPS coordinates of the track and split it into evenly divided positions with a clear start line, finish line, etc. And that enables us, first of all, to do lap counting, make sure that you have the right number of laps, the distance traveled, which is very important for the World Championship displays. We can calculate what your exact time on track is. We can keep track of any speed violations. And very important from this, we can do any GPS corrections where that's still necessary. As you can see in the picture here, we had a big bridge in London that Benny alluded to as well, where we had teams, the GPS data show them as being on the shopping mall nearby, and our kinetic service makes sure to estimate where the correct location is so that we always show the teams as appearing on track. The OBC manager is the interface that we use as the data and technology team to keep track of all the OBCs that are used at the event. It gives us a clean overview of the status of all the OBCs. Is it green? Is it good to go? Is there a potential problem? We can see individual sensors, what their current status is. We can see if the battery has sufficiently been charged. We can keep track of the speed and if there have been any speed violations. But we can also zoom in on individual sensors and, for example, get down to the detail of the liquid flow meter, what the exact real-time temperature is of the fuel flowing through. Lastly, we use this process data from the kinetic service to present visualization, so a real-time view of where teams are on track during the World Championship, their exact energy remaining, their ranking on the track. And we also make the data externally available to partners so that you can see, for example, on Facebook Live and stream to all of your friends how you are doing in this competition. That's everything for live data. And with that, I'll hand it over to Ankit and Cole from Southwest Research to talk about log file processing. Thank you.
Hello all. My name is Ankit Chaudhary, and I am a senior research engineer at Southwest Research Institute. I've been working with Shell Marathon for about 6 years now. Cole and I mostly take care of the maintenance of liquid flow meters, and in addition to that, we also process and transmit the telemetry data to students after the attempt is complete. So today I'll go over some of the data analytics we do and some of the things we provide to the students. So as Martin mentioned earlier, every onboard computer, besides sending the data live to the IoT, also generates a log file that once parsed will be able to provide some raw sensor data as well as some raw GPS coordinates. So we take this log file, parse it, and then filter it to some extent and send it to students, upload to a portal where students can access their data after their attempt is done. This way they can use their own software they like to process the data. So as part of the data provided to the students, we provide the GPS coordinates, raw liquid flow meter data, raw joule meter data, raw gas flow meter data, and some of the calculated fields to convert units to different units or the temperature corrected values for the flow meters. The frequency of the data provided, so for GPS, we provide the data at 1 Hertz. And then for the rest of the sensor data, the data provided is at 10 Hertz. So once we have the data ready to upload, we upload a set of files. So the set of files include a PDF with all the plots for the quick glance. We keep playing with these plots, so they change from event to event sometimes. We also could provide a CSV with raw data, so you guys can go in and use your software and play with the data. We also provide another CSV with filtered data. So we take the start line coordinates and the finish line coordinates and basically filter the data before and after the event. And this gives us a clean data set for just the time that you guys spend on track. And then, of course, added is some other plots. So I'll go over the GPS data provided first. So this table contains the list of columns that we provide for GPS. So of course, we provide you the timestamp for the GPS, the validity, the dilution that can give you an indication how good the GPS signal is at that point. Lastly, the most important thing is we provide you the GPS latitude, which is negative for south and positive for north, and then the GPS longitude, which is negative for west and positive for east. This is provided in decimal degrees. And then from this raw data, we will calculate the number of laps. Again, we use the start line and finish line coordinates. We divide up the data per lap, and this way we can further see what's happening from lap to lap. We also calculate the distance between the 2 GPS points we get. So we're getting the GPS points at every second at 1 Hertz. So we'll take those 2 points, calculate the distance between that. Then we give you the total distance around the track. This can help, find the shortest distance around the time, follow a race line, stuff like that. And then we also provide you speed in meters per second, which is just a converted speed, raw speed from kilometer per hour. So this is an example plot that can be done quickly in a software like Microsoft Excel or Google Sheets. You can plot latitude versus longitude, and gives you an overview of around the track. And then I also added the start line, finish line, and the lap line in this plot. So this table provides the column names for the joule meter data. So for joule meter, we provide you with the net joules used, the voltage, and the joule meter current. From these values, for example, the power can be calculated and other parameters can be calculated. So As an example of plots, I've provided the volts, amp, and power versus time, so you can see how you're using the electrical power over the course of the race, and also a plot showing, you know, the net joules. So, you know, as the race goes on, your consumption keeps going up. So for liquid flow meter and gas flow meters, the raw values provided are the temperature, the integrated flow, which is the cumulative flow, and then the instantaneous flow. And same for gas flow, the temperature, the cumulative flow, and the instantaneous. The calculated fields here will be the corrected flow, cumulative flow, that we will use the temperature as, you know, depending on what fuel we are using, diesel, gasoline, the density will slightly differ depending on the fuel as well as depending on the temperature. So we'll calculate that, and then the instantaneous flow. So in this slide, I provided some example plots for liquid flow meters. So one is just temperature, you know, as you guys are going around the track, the engine compartment's getting hot, and the temperature of the fuel will go up. On the right side plot, I provided two plots. So one is your cumulative flow, which is the orange line. So as you guys are going around the track, you're using more fuel, so total net fuel use will go up. The blue line is the instantaneous flow. And this, you know, as you're accelerating, there will be a spike in the instantaneous flow. This also let us know if there's any, you know, issues like bubbles in the system or something that we need to be aware of. But this is like a typical flow rate. So at this point, I'll hand it over to my coworker, Cole Hudson. He'll go over some of the data processing workflow we use and some of the open source software we're using.
Thank you, Ankit. Yeah, so my name's Cole Hudson. I'm also a senior research engineer at Southwest Research in Texas, where I do driveline testing and automotive research, in addition to helping you know, Shell with the Eco Marathon. We wanted to give you guys a little bit of a window into maybe what our workflow looks like in looking at these log files, sort of manually, and hopefully can, like Marco was talking about earlier, you know, spark some ideas, but also give you guys a foundation for analysis that you can use to improve your mileage attempts at the event. All the tools that you're going to see used in the next few slides are all free and open source. This is the same stack that, you know, that we use, but all of this stuff is available for you to download yourself online. Now, that's not to say that we made any compromises here. This stack is very powerful and widely used, and is you know, the industry standard for doing this type of real quick iterative data analysis or dashboarding. If installing each of these components is a little bit intimidating, the Anaconda Python distribution is a really good sort of quick start. It comes with all of these already pre-installed. So on the right-hand side of these next few slides, you're going to see the cells of this example Jupyter notebook. So that's one thing that's really nice about Jupyter and makes it perfect for this type of analysis, is a cell-by-cell execution, allowing you to iterate quickly over you know, different versions of your code, and then clean it up as necessary. So we're not going to go through this line by line, but just sort of give you an idea of what's going on here. So we're, you know, importing some libraries, and then we're importing the log file. So this is an actual log file from London in 2019. We're going to clean up the column names a little bit, and then we're going to forward fill that data frame. So this ensures that we don't have any null values in any of the rows, so that we have nice continuous traces that we can use for the visualizations that you'll see here in a little bit. And then we'll dump the first handful of rows to a table that is interactive in the notebook, just so we can see it, make sure that that we have everything imported the way that we want. We then will just define the start, finish, and lap lines for this particular track. So this is something that we do as part of our as part of this analysis at every event. These coordinates are not something we've provided for the students in the past, but if this is something that you want for your own analysis, all you have to do is ask, and we can provide that for you. So we define those lines, and then we'll just plot the GPS coordinates here. So this is, all of the laps are sort of on top of each other here. You can see over here near the start line, there's the, the drive out of the start tent and across the start line. This is a good opportunity to highlight the plotting library that we're using here, which happens to be Plotly. There's a wide range of plotting libraries you can use with Jupyter and with Python. This is the one that we're using for this example. It's nice because it's interactive. You can zoom, pan, you can turn traces on and off, you can export. It supports hover info. It's good for this sort of ad hoc analysis. So then we will do the line crossings. We'll calculate when the car that is the subject of this log file has crossed the start, finish, or lap lines. We use a pretty efficient line segment intersection algorithm to do that, it fits well with the tabular data analysis library we're using, which is Pandas, which supports these vectorized calculations. The way this works, you can kind of see in this simplified example here. You can imagine just a car driving in a circle. You get these discrete points, with a timestamp and GPS coordinates, and then we just draw lines between all those GPS coordinates. And then anytime that line segment from one point to the next crosses one of the line segments we've defined as the start, finish, or lap lines, we flag it. And then this last cell here, we're just truncating the data set to all of the data between your first start line crossing and your last finish line crossing. So the outlap is ignored, and then the lead out of the start tent up to the start line is also ignored. So we have this new dimension in the data now, which is the lap number. So similarly to the GPS stuff that we plotted earlier, we will just quickly dump that to a plot and make sure it looks like we expect. So you can see each one of the traces here is a different color for a different lap. So we're starting to get to the point where the data is it's granular enough that you can do some useful analysis. So that's this last cell down here. We're going to do the time, the liquid flow meter consumption, and the joule meter readings per lap. And then we can plot that. So these are just one-liners to plot this data now that we have these dimensions in the data frame. So we have the fuel consumption, the cumulative fuel consumption as indicated by the liquid flow meter, and the cumulative energy consumption is indicated by the joule meter here on these two plots. So you can start to see how this might be useful, right? Like you can look at this, you can see what your best lap was, you can see what your worst lap was, and you might be able to provide feedback to the driver or to other members of your team. But it's still a little tough to tell exactly what's going on. So we'll do a little bit better on the next slide here, where we take this is just the liquid flow meter stuff. You could do this for any of the other numeric data in the data frame, but we'll take that liquid flow meter data and we'll overlay it as a color map onto the GPS data, and then split that out into a facet plot of all the individual laps. So now here at a glance, you have all of the laps for this particular attempt laid out, and you can see when the longest, hottest burns were, when you had nice short tight burns, and what was your best lap, what was your worst lap, and then this provides feedback, or this provides information that you can use to give actionable feedback to the driver, to other members of your team, right? You can tell them to do what they did on lap 2 in corner 3 instead of trying to squint at time series plots and figure out exactly what was going on there. So hopefully this is useful to you guys. If you have any questions, stick them in the Q&A, and I'll hand it back to Ankit to talk about what we're doing with the data now and what we plan to do with it in the future.
Thanks, Cole. So as we presented to you guys today, the current uses of data, we're using it for visualization. We are also using for world championships. We're going to start using this for automated energy measurements. And also we have implemented data processing framework, which is going to speed up the processing of the data live as well as post event. So the future improvements that we are thinking to the student files are, some of them are energy consumption per lap. One of the example was shown by Cole just now. We can do facet plots to add more stuff, more sensor data to each lap plot. We can also, we're also thinking of doing a lat-long plot showing the race line followed, so we can kind of optimize on the shortest distance around the track. Some of the other plots we can do is average speed and time per lap. The most important upgrade we're thinking of doing is making the student, the data that goes to the student portal, making it interactive so students can play with the data online. We'll have a dashboard ready so they can drag and drop stuff to look at the data quicker. So that's all we have plans for. So from here, I'll give it to Marco to talk about the award.
Yeah, thank you, Ankit, and thank you guys for providing us this under the hood life experience. I hope it gave some inspiration to the audience. We now move to the next step. We look how we can prepare for the award and what we expect from you. To do a recap, we have seen how the data points are created right in the onboard computer, right in the vehicle, how we send the data to a cloud server, from there do some visualizations live, and also how we produce the log files, how we can massage this data. And most of all, it's now open to you. You open the blue sky now for your new crazy and hopefully also disruptive ideas. So we really are curious of what they get, and please surprise us. And your next step will be to submit a document, containing a summary, design and analysis, how you use the data, communication strategy, and many other words that really describe the team's approach, how to use data. We ask you to address some key questions. What data will you use from the existing telemetry system? Are there some data that you could need that is not already available? And how will you use the data? What data will be communicated between the driver and the team? And what will the driver do with this data? And very important, what is the expected outcome from the use of the data? And most importantly, how much of an improvement do you expect and why? Submission is open now. And the deadline, please observe, it's March 3rd, 23 hours, 59 minutes GMT. And boy, there are prizes waiting for you, not only monetary prizes, but also virtual league points. And with that, we close this technical part of the webinar and move on to the Q&A. And with that, I hand back to you, Priscilla.
Thanks, Marco. Yes, lovely presentation. Thank you guys so much for this very thorough and insightful presentation for the students. I hope they found it helpful as well. We already have a lot of questions on Menti, but you still have time, guys, to submit more questions if you wish. So as we said, if you're on your desktop in your computer, simply use the box to the right side of the window that's showing the video. And if you're on your mobile phone, can go to menti.com and type in the code 9156404 to submit your questions. Shall we get started? Joe?
Yes, thank you, Priscilla. Well, my name is Joe Redfield. I've had the opportunity to be associated with the Shell Eco Marathon and supporting it for 10 years now. I am the e-mobility expert associated with all things battery electric and such. I will be leading the questions here. We have a number of them listed, and we're just going to start from the top. And I think we've covered some of this material, but the first set of questions, Marco, are for you, and we'll just go through them one at a time. And one of them, the first one is, what do you expect from the teams? And I'm assuming this question is around the off-track award.
Yeah, I would say read the article 102. Maybe go through the video again. I think we have presented everything that we expect from the teams. It's about, creating the document with the content that I was running through. Address the questions here, and according to these questions, we do also the scoring. That's what we expect from team, and we expect to submit papers, as many as you like.
Great. Yeah, great, Marco. The next question is a very important one here, and that reads, can both prototype and urban concept teams apply for the off-track award?
Yes, certainly. Because as you know, the telemetry system has been used only in the urban concept so far. But as Benny has shown, our future roadmap also includes a much smaller telemetry system onboard computer that will also be supplied to the prototypes. That's why, yeah, please also submit from the prototype area. We encourage that.
Great, thank you, Marco. The next question is kind of a general one, and for everybody on the team here, it is near and dear to our heart. What is data in telemetry? I think the general question is, what's the overall high-level scope of the team as it relates to the Telemetry Off-Track Award?
Yeah, data itself is kind of the basis that give you facts, give you facts how to improve your strategy. Data is created somewhere, and data is normally created, where data is, where data happens, so that's in the vehicles, like the speed, like the energy consumption. The telemetry is just a vehicle to get these data from the cars into the cloud and from there to a log file. And from there, you can use it and do what you want.
Great, thank you, Marco. The next question is for Ankit. And is the OBC module and telemetry system available for teams to use or just for the Shell car?
So at this point, the OBC module and telemetry system is available for teams at the event. For urban concept cars. So when you guys show up at the event, we give you one OBC module and the sensors depending on your energy type, and then you have it for the duration of the event, and at the end of the event we collect it back. So at this point, that's what we are doing, but you're welcome to use it at the event as much as you want.
Great, thank you, Ankit. There's a couple of questions that I will address. And the first one is, I think is, Marco, you've already addressed it earlier, but we'll cover it again. Where can we find more details about the Data and Telemetry Award? And as Marco indicated, go to articles in the Chapter 1 rules. It describes everything that we're looking for, and it describes the content and the format for the award submission. The second question here that I will address is, can we buy a joule meter from you? And the answer at this point is no. These joule meters are built specifically for the Shell Eco Marathon. For use, they're tailored for what we're using and what we're trying to achieve with high accuracy, high temperature stability. Now, having said that, what we have found in the radio controlled market, there are other joule meters that are available, not quite as accurate and not quite as temperature stable as ours, but teams can find these on the market. They're not that expensive. and can use that for testing. And the next question is getting into some more of the technical aspects, and I'll direct that to Mela. And that is, there's several of them related to this. Can we be provided with APIs to interface with the JSON F data?
Very good question. Just before I answer, I noticed that there are some questions coming in with people asking if we can share information at their email address. I just want to point out that this is a public Q&A and the session is being recorded. So please don't share any personal data in the Q&A section. Just email the student comms team with your questions, please. So sorry, back to the question. Can we be provided with the APIs to interface with the JSON data? This is something that is on our roadmap. We are looking to give this make this data available to you real time, but it is being phased very much. So right now it is post-attempt, the log files that Ankit is processing together with Cole. We share those to you. You will be provided a link before or at the start of the event where you can download your log files. But yes, we are looking at the future to providing you with the real-time data. And for the purposes of the off-track award, of course, you could assume that you do have access to a real-time interface. It's entirely up to you.
Great, thank you. And you may have already answered this question, but there's another related API question. Will there be an API to retrieve live data or just simple connection to the MQTT broker will be necessary?
Yeah, this is still to be determined, really. We are looking, again, to give you access to real-time interface, whether that will be through some form of API, streaming API, or through the MQTT broker. That's not been decided yet.
Great, thank you, Mela. The next question is a detailed question around GPS, and it'll be directed to Ankit and Martin. We can do a tag team response. And it reads, can we have information about acceleration, X, Y, and Z, rotation around axis or rotational, and then other values measured by an accelerometer, or are they calculated?
Well, to make the answer very short, the data are just useless because they're raw output of the acceleration sensors, and we're missing the sensor fusion. So that's why we can't do anything with that data. We have something on the roadmap for the next OBC with a proper sensor fusion. So you will have them. We will have them on the roadmap.
Great, thank you, Martin. Anything to add to that, Ankit?
No, I think Martin covered it pretty good. Yeah, so we're right now we just don't have enough resolution, if you can say, but we'll get that data to you in the future. So
great, thank you. So the next question is one that I'll answer. And it reads, can we retrofit these sensors discussed in cars that exist on roads already? I'm not quite sure I understand the question, but I will just reiterate, as the team presented earlier, we have several different sensors we're using in the Shell Eco Marathon vehicles to measure energy input for the different energy categories. So these are tailored to provide the data that we need for our telemetry system. So I don't know that there's any opportunity to retrofit sensors that are used in specific passenger vehicles or on the road. So if that didn't answer your question, please resubmit, or as Priscilla mentioned earlier, you can always ask questions through the normal email submittals, and they will be directed to us. So the next question I will address toward Mela, and that, which cloud do you use for the SIM kinetic device?
The kinetic the Kinetic service. We're running everything on Microsoft Azure platform as it stands right now.
Great, thank you. And the other one is for Cole. Why aren't the log files processed in the cloud as well?
Yes, that's a good question. So historically, the uses of the data that was being transmitted over MQTT in the cloud and the data that was given to the students, those two branches sort of grew separately and had different goals. But that being said, we did just recently lay the foundation for a more overarching or holistic processing framework to where there can be a single source of data and then the aggregate data to serve any calculations or analysis or distribution from there.
All right, thank you, Cole.
Yep.
Here's one for Mela, is what does MQTT mean?
I have to admit, I actually had to cheat and look that one up. It's the message queuing telemetry transport protocol. It is kind of a standard used in IoT services. It's pretty, to put it back to basics, it's pretty much a message bus just used for relaying messages. So it's able to aggregate all of the messages from all the different OBCs, and the Kinetic service is able to read from that, as well as send back commands down to the OBC.
Great, thank you. The next question, we've got a bunch of them here. These are great. Goes to Ankit, and it reads, is the data provided to the team on a real-time basis, per lap basis, per attempt basis, or after the whole event is finished?
So up till now, we've been providing the data to students after the attempt is complete. We are working towards getting the data for them at per lap basis. So hopefully we will be able to implement some solutions that, you're getting it maybe after 2-3 laps are completed or something like that. And then of course, the next step would be to get the real time basis data. So yeah, so we're working towards it, but at this point we have per attempt basis.
Great, thank you. And Mela, I think this is one that just was generated as a result of your section, and it was, what is the top speed?
What is the top speed? I'm not sure I understand the correction right. If we're talking about maximum speed, I think that's a little bit dependent on the track where it's located, as well as mileage challenge versus world championship. In the world championship, we have a maximum speed of 40 kilometers per hour. Now, if you're asking what has been the top speed that we've seen cars driving, I will not comment. We have had speed violations, yes. And yeah, I'll leave it at that.
Yes. So I have a question here, and let's see now. I will point it to Benny, and we may have to punt on this one a little bit, but it is, do we need an encoder to interface with the IMU?
Well, maybe I can take over that because it's related to the previous question. That's exactly the part we're missing, the sensor fusion. We can have the raw sensor data, and the factory of the sensor provides a sensor fusion, but pre-compiled, which is not available for our platform. So that's why we need to wait for the next OBC with the integrated fusion.
Great, thank you, Martin. And here is one for Ankit. And the question is, why load road and BSFC don't show up on my Shell data telemetry?
So right now, to calculate the load road force as well as the brake specific fuel consumption, we need other pieces of data. So like the drag the car's producing, and you know, other stuff like friction between the tires and the road. So it depends on the event. So we're working towards collecting all the data. The reason we have it there, so we can have students make assumptions and calculate their own BFC if they needed to. So that's something that we are working towards, but right now that's why it's empty. Cole, do you have anything to add to that?
No, yeah, that pretty much covers it. I think it's, you know, I understand how useful, you know, a parameter that would be for everybody. But yeah, this kind of stuff, these are things that Ankit and I do in our jobs, but that's usually calculated from the other direction, right? It's and then usually in, you know, climate controlled chassis dynos, so it's something that's difficult to do using onboard sensors. But if you have enough inputs, you know, you can do it, and that's, yeah, like Ankit said, what we really would like to work towards.
Great, thank you. And the next question here is for Benny. And the question reads, can we have technical drawings or CAD models of the joule meter and the OBC antenna module to design their place in the vehicle?
Thank you, Joe. The drawings are not yet available publicly, but we're working on this. And once they're available, we'll let you know through the normal communication channels.
Great, thank you, Benny. And then the next question I'll take here, it is March 3rd the final date for the submission? Can we submit a report by March 3rd and have the telemetry system ready by the time the mini marathon takes place? So this is a very important question that I want to ensure that everybody on the call understands. The off-track award and the submission for the off-track award does not have to be based on a physical telemetry system that you have or you're planning to use. It is a submission that would look at, as Marco indicated, possibly some blue sky, possibly some future concepts of, if you had data, what would you do with it? How would you use it? How would you communicate that data, or what data would you communicate to the driver real time? And how much improvement and why would you expect to get in the mileage challenge? So again, the off-track award does not require you to build your own telemetry system. So the next question that I will pick here, and this will go to Ankit, and it is, will we be provided the GPS data of other teams during the race in the future?
Yeah, no, we're keeping all the data from each team separate. So no, we're not gonna provide, you know, other teams' GPS data, although it doesn't have any information about the car. Still, we're keeping each sensor separate. Yeah.
Great, thank you, Ankit. And here's another related question to the one I just answered. You know, are we allowed to use our own telemetry system or other forms of data for the concept for this award? And as I just indicated previously, the answer is yes. And let me get through the questions here. and this is one I believe we've answered previously, but I want to make sure it gets captured, and this is Ankit. You know, how can the teams access live data during the competition?
So the live data during the competition is not accessible right now. The only data we are providing is the log file, processed log file data, which is available after the attempt is complete. That will be uploaded to a portal. So when you guys collect the OBC module, the box has your username and password, and you can log into the portal using those credentials, and then you can see the data after the attempt. In future, we're working towards getting you the data quicker. So you might have live data in the future.
Yeah, thank you, Ankit. The next question, and I'll point this one toward Mela, is the coordinate points of the track provided for the teams before the start of the race, so we can use our own telemetry system?
I'm not sure I'm understanding the question right. If it is regarding the node map that we use for our kinetic service, traditionally we have not made that available to teams, just because it's primarily used for our own internal processing. If there is an interest in such a thing, please reach out to the student comms team, let them know your interest, and we can look at making that available to you.
Thank you. Great. And this is, again, one that I believe we've answered, but I want to make sure we get through the list. And this is to Ankit. Is it fine if the data is provided after the run, or is it necessary to provide data while the car is on the run? And I'm not clear whether we're talking about the off-track award, or we're talking about the telemetry system and the data available on the mileage challenge, and possibly, Ankit, you can answer both.
So for the mileage challenge, the data will be provided after the event. Attempt for DWC or World Championship, the data will be provided after the whole competition is complete. For the award, you guys are welcome to use any data. I'm not sure if I'm understanding the question right, but I think you guys can use any type of data. What we're looking for is, you know, what you can come up with that data, or what future data that you might like to make something, you know, better.
Right. Thank you.
Mel, do you have something you want to add? Yeah.
Yeah, it is actually what you just covered, but I want to make clear, we're showing how we're using live data. We're showing how we're using an MQTT broker and a kinetic service to do the processing, etc. But for your off-track award, by all means, you're welcome to tell us how you would leverage that and how you would enrich it with more data even. But you're also welcome to tell us, I've got a much better solution. I don't like MQTT. I've got a better protocol here. We welcome all your ideas for this specific award.
Great, thank you for that addition. Here is a relatively technical question, and Ankit, I'll point it toward you. For GPS speed and current measurements, there is normally an offset, 1 or 2 seconds, related to the GPS operation and a given measurement. Is this offset compensated for, or is the offset in the raw data?
So at this point, we're providing the raw data. So I haven't noticed offset. So if you guys are seeing an offset, maybe you guys are comparing to a different telemetry system that you are using on your car. Maybe that's why you're seeing an offset, but whatever I am giving you guys is the raw data that as it comes from the sensor. Now there is some type of processing and smoothing of data when we are showing live just to make it clean, but that's all we're doing to that. I don't know, Mel, if you have anything that you process to compensate for offset during live data.
No, I don't have anything specific to comment. I don't know if Martin, do you have any insights in this from the GPS module itself?
Yeah, not very concrete, but that's the point we need to address in the telemetry software. So,
well, some of it just comes from the way it is measured, because the GPS module, as it is now, produces one measurement point per second, and we're transmitting once per second to the IoT, for example. And so this is asynchronous, and you will see some delays coming from that topology.
Yeah. Great, thank you. And here's another question that's come in, and I'll direct this one to you, Mela. Is it possible to have an accurate estimation of the slope and altitude of the track?
It's kind of similar answer to the points of the node map. We have not historically provided any such information. There isn't anything planned right now, but if there is an interest, please reach out to the student comms team, let them know that you're looking for this, and we can look at how we could potentially provide this to you.
Great, thank you. And this next question is one that I will address. And the question reads, will we be provided with power source for this telemetry system, OBC and other things required? And just as a reminder of what Marco presented, or Benny presented, is at the event, the Shell provided telemetry equipment that will be installed on your urban concept vehicle will be powered from a completely separate battery that is used just to power the telemetry equipment. So the answer is yes, on track with the Shell telemetry equipment that will be installed on your urban concept vehicle, it will be self-powered. Okay, the next question, let me see here. And this one, Marco, I'll send it to you. And it reads, if a team uses its own telemetry system for testing and optimization purposes in their trials to prepare for the competition, would it be something you want to see included on the award submission? And I'm assuming they're making reference, it's being referenced to the off-track award.
Yeah, I would say so, because this means we encourage to use data points that are not already available. So instead of doing some theoretical views into that topic, why not use real data that you already have and add it to the concept? Yes, we would encourage that, of course.
And then I will let you, again, address the very similar related question. Is it possible to send your own data besides the data is required? I'm assuming the question is it possible to use your own data for the off-track award submission rather than the data sets that are provided through the telemetry equipment?
Yeah, I think that's the same thing. Because, you know, here it's not about building a new telemetry system, it's about using the concept of data. So it's more about ideas and exploration and maybe make even the existing telemetry better in the future.
Right, and Marco, here's another question for you. And there's several of them that kind of go into the off-track award about how it's going to be judged and what we want to see in it. And I'll read through these questions, but I certainly encourage all the team members to review Chapter 1 rules, because that defines how things will be evaluated. But so, Marco, this question reads, would you prefer high accuracy but less creative, or more creative but not as accurate?
In the end, it's all about getting more performance. And maybe sometimes the creative way is the better one. Maybe there are some ideas coming you would never have thought about. It's really difficult to answer that one right at the moment. So anyone else having some complementary ideas?
I think this is the same answer for all of track award. The creativity you demonstrate in your explanation, documentation, more creative you are in your document, more chance you have to be the winner, or at least top. But it's also up to you to find the best way to demonstrate what we ask. We don't want to give you too much guidance, which criteria are more important than the other. It's exactly like in life when you have to make presentation to a jury. The way you are presenting could make a difference, and yes, it's where we want to see the difference between all of the teams. Yeah.
Great, thank you for that addition, Gilles. And Benny, the next question here, I'm going to direct toward you. Are we allowed to interface directly to the OBC?
The short answer is no, but I'd like to explain why. We'd like to have equal we would like to make it equal for all teams, and if you can access to the OBC itself, you could possibly change the measurements in there, so that we don't want to give teams access to that one. If you want to have a telemetry system that you can access to, you still have to build your own.
Great, thank you, Benny. The
Joe,
next question. Yeah, go ahead, Priscilla.
Yeah, sorry, just to remind people, we're almost at the 10-minute mark now to finish our Q&A. We still have some questions to go through, but I would just like to ask the teams, if your question is more general, or it doesn't necessarily have to do directly with the Data and Telemetry Award, please do send them to your regional inbox. And for this session here, please try to ask more specific questions or more related to the Data and Telemetry Award, because we did have some great questions in a lot of them, which is awesome. So thank you guys for your participation. But yeah, just if you could stay on topic for this one, so we make the most of the time. And just to answer some of the most popular questions, yes, this session is being recorded, and we will share the recordings and the materials with you once we are done here. So yeah, sorry, go ahead, Joe.
Oh, thank you very much. And I'm wading through the questions here. Again, some really good questions submitted. Thank you for participating. And Priscilla, really thank you for keeping us on time track-wise, on track time-wise. The next question I will address: how is the current measured in the joule meter? Low side, high side, or both? And the current is measured in the joule meter through a current shunt that at this point is on the negative bus. That is how the current is measured in the existing joule meters. The next question here is one for Cole, and that is, what platforms do you use to deliver the Juniper data live?
I guess if I'm understanding the question correctly, I'll take a stab at it. So the notebook that you saw presented earlier was an example of some analysis and not necessarily how it's done, I guess, in production, if you will, I guess. So usually our workflow, we'll do prove out in a notebook, and then that will be translated to a standalone script that can be run as a service or scheduled. And I know there are some tools out there for moving notebooks into production. I think Paper Mill is one that comes to mind, but that's not something that we do. So hopefully I understood the question correctly, but that's yeah.
Great, thank you. And here's one for you, Ankit. Why some of our shell telemetry data show up as NAT, NAN?
So NAN will show up if, for example, I'll give you guys an example. So let's say you guys, I provide you the raw data and the GPS, you just started the OBC and the GPS signal hasn't like fully gained or hasn't connected yet. So up till that point where we get full GPS signal, the GPS coordinate will be empty, or some of the software will read it as NATs, which is, null data. And so when you see NAN, either the sensor's booting up or there's a problem with the sensor. If it's at the start of the log file, it's usually the sensors are booting up because I am providing you guys the raw data. So I hope this answers the question. Yeah.
Thank you, Ankit. And the next one is for you, Mela. Will MQTT networking services be provided for free if we decide to implement our own telemetry system?
So to differentiate a little bit between the award and the actual live event, for your award entry, you can assume any capabilities available to you. If you are looking to physically develop a new system, no, we will not be providing an MQTT networking service for you.
Great, thank you. Here I'm looking for the remaining questions, those that may appear to be relevant here. I see one question. It's more as a comment question together that I will address. It means for prototype carrier, we won't be provided with a power source. I believe that is a follow-on or related question to dealing with the Shell provided telemetry equipment. And in our roadmap, we spoke of telemetry equipment being available for the prototype category, prototype vehicles. That is a future capability. And when that happens, there will be a power source that will provide that telemetry equipment as it does with the urban concepts right now. And so with this, Priscilla, I will give it back to you and see if there were any other questions that may not necessarily have been technical in nature, and give it to you to kind of wrap things up here as we're getting close to the end of the call.
Thank you, Joe. Yeah, I think we covered most, if not all, of the technical questions. So thanks again to all the teams who participated. We had a great turnout today. If we've missed anything, or if something is still unclear from what you heard here today, I would encourage you again to reach out to us via your regional inbox, the usual Shell Marathon channels that you communicate with us. Some reminders is that not for the abstracts, but let's start with the autonomous programming competition that's ongoing at the moment. I'm not sure how many of you guys are taking part in that, but the technical submissions end on February 19th. The Off-Track Awards, as you know, has just opened on February 1st, and submissions will close on March 3rd at 23:59 GMT. Please be careful with the time zones, because we've had issues with teams, submitting things after the deadline, because they we're not paying attention to the time zone. So please be careful with that. And then after that, we still have the virtual technical inspection, which will have submissions will stay open from March 8th to the 31st. And who knows, maybe some other bonus challenges popping up during the season. Stay tuned for that as well. And yes, I hope this has been a helpful, informative session for all of you. Hope you guys enjoyed the time. Here I'm seeing some questions here. This is thank you. So we thank you guys for the time and for the attention, again, for the excellent questions that we saw here from a lot of teams. And we hope this was a good use of your time. It was, surely an enjoyable time for us, getting to see what kind of questions you have about the Data and Telemetry Award, this new category that we are launching in 2021. With that, Joe, thank you so much for handling the questions here. I also thank all of the Schmidt team and the Southwest Research Institute team, and all the technical experts. Mela, I won't name all of you, but all of you who contributed to this fantastic session. I thank all of you for your time. With that, I say goodbye and see you on the next one.